And we are live. This is the May 25th, 2015 e-NABLE R&D Hangout. It's Labor Day, or I'm sorry, Memorial Day, so I'm at home rather than at work, so the lights are a little awkward. The window behind me at the house is very bright, and the room is not, so I tend to come out very, very dim in the corner. Sorry about that. I've been sending invites out. If anybody still needs one, send a chat to me, and I will.
You get one to skip, or the 3 Lydias.
I did. There are 3 Lydias. Oh, well, one of them joined. Hi, Lydia. I did send one to Skip. I'll send another.
You get Ellis Wood.
No, not yet. Let me get him.
Yeah, you know you're live, right?
I do.
Okay.
I figured people didn't seem to be responding to the invites, so I figured if I go live, maybe the people will know that it started.
Okay. Well, I'm gonna IM you something because I don't want to say it on live.
Oh, sounds good.
Hello, everybody.
Hey,
Hello.
Is that Les? Yep.
Yeah, hi, Nick.
I think I need to turn my own volume way down, because that way I think the feedback loop's going to be on my side when I'm at the house.
I'm sorry, I'm running my printer. It'll be done soon.
No worries.
I'm making one of these big vases.
Oh, yeah.
It's pretty large. For a little printer to do.
Okay. I will send
And it's
an
done.
invite from the event rather than from the Hangout for that one, Lydia.
Okay. Oh, wait.
They are welcome to join as a participant, too, if they wish.
I don't think they want to. I think they just want to see what this is all about.
Fair enough.
So what did you say? You invited them not the normal way inside the call?
No, I'm done the usual way with the call.
Oh, okay.
No, I said I can invite. Your chat said you wanted to invite them to join as a spectator, so I said I was going to invite them through the event host rather than through the through the Hangout.
Okay. Well, as long as you did the little thingy inside this Hangout, then that should be fine.
All right. Mess with the audio levels a bit. And could you go ahead and talk for a second, Lydia?
Okay.
Okay, much clearer. Sorry,
Right.
my audio levels, some of the people were drowning everybody else out, and others were really, really quiet, and so I was trying to make little adjustments to volume just to try to get everything kind of clear.
Right.
All right.
So you
Go
don't.
back and look at the.
Yeah. So they'll show up when and if they can because they're kind of new at this. So I'm walking them through how to get to the place where they're invited.
You invite to actually join the call the person on the sidebar. Just pasted the link. Thanks. Didn't realize that. Yeah.
Open that new tab.
It's kind of noisy here, so I'm pretty much staying muted, but I'm here. But it's just there's a lot of background noise here right now,
Totally
It's
fine.
all good.
just so you know.
Doesn't seem to be helping much, and
You're adjusting the levels on the board thing that you guys get.
yeah, I was adjusting levels on the board on the side. The plugin for host, I guess. This person you posted in the sidebar, should I add them to my e-NABLE
Pretty
circle?
cool.
Or?
Yeah. Oh, sure. Yeah. They're someone from RepRap. So.
Okay. I will send them an invite as well.
Did you send him one?
Trying to. I just circled them, but they're still. I'll probably have to refresh the page before they become a. Let's see.
Hey.
Oh yeah. Generally, it's if somebody hasn't done the circle back and forth, Google Plus may not allow it because it hasn't had a chance to go through the system. That's why we do inviting people by email address if it's a thing where the person hasn't been in our circle before.
Do you think you could, in the private chat that you had started with me when you asked me to invite you, if you could give me their email address, that might be an easier way for me to invite them.
Sure.
I wanted to invite.
Maybe they're just gonna watch silly hangouts.
Okay, that works. I will share the event with them, maybe. Refresh the event page. So they want to watch, they don't want to participate?
Yeah. Yep. Cool.
So you said you almost got your new printer, or you got a printer working again?
Yeah, I have a Rostock Max I just finished building this weekend. Well, started and finished, but.
I saw your posts related to it in your stream.
Hang on, I'm reading a paper again before I have something interesting to talk about.
Hey, Skip's here.
Hi, Skip.
Hi, folks.
It's so quiet.
Yeah, sorry.
Nobody say anything.
Hi, folks.
Hey there.
Yeah, right now I'm trying to send invites to people.
Yeah, yeah. You look
That's a good-
funny. You're kind of in the dark, and your screen is reflecting off your glasses. So you're like.
Yeah, it's
You're called
when I'm at home, the light is a little bit odd. there's so much brightness from behind me, and the screen tends to be not quite bright enough to overcome the window behind me, but still bright enough to reflect off my glasses.
Oh, wait.
I'm trying to. Sorry, that was loud through the mic, wasn't it? I'm trying to find the part of that Dan Oakes paper that says like what the actual capacitive sensor component is and where we might buy some. So, I guess brief update from me. I've started my summer job, lots of fun, takes up pretty much all my time on the weeks, but because it's a job and not school, it means I have this wonderful thing called work-life balance, where outside of work, I'm not working. So weekends are basically going to be e-NABLE time now, which is great.
Oh, nice.
Okay, I sent an invite to Red Rabbit. It took a minute
Okay,
for.
yeah, he's got it. He's watching the stream. It doesn't need a
Cool.
invite.
Good. So I was looking at the Hackberry email, or the post that Aaron Brown and John Wong both posted about.
Yeah, I saw it through John.
Right. I was looking at the files earlier.
I bet it's complicated.
I haven't looked at the files yet. I've just noticed that they exist. Do you know if they are multiple EMG sensors, or is it just one, or like we were talking about last event, where you have two EMG sensors, one to toggle what grasping mode the hand is in, and the other to initiate and release a grasp?
Not sure.
Yeah.
I was just looking at it too, but I haven't caught up on that yet. I think their lawyers are a bit more worried than ours are. They have a lot of disclaimers on their GitHub.
Right.
Okay, step file. I can open that.
I've got more responses.
It's a little bit
Okay.
sleepy.
I'm pulling the download. I'll have that open, and I can talk about it and stream it in a sec here. In the meantime, what am I doing? Okay, now's not a good time to try and find that.
Okay, there's a few that are on the wanna watch that invites out to. You send to Eric Griffin, to David Stonier Gibson, Jim Squirrel, Sanju Matthew. I sent one to Keith Johnson, but let me try it again. Ellis Wood and Charles Wainthal. So I guess what all do we have going on? I was noticing Les has been posting about his the sensor. Is that what you were talking about a minute ago, Nick?
No, I'm talking about a different thing, but he should talk about his while I try and find things.
Okay. I can do that, Nick. Well, it just, I mean, I kind of wandered off and got into music and was messing around with music controllers and, capacitive touch, capacitive sensing is right up the alley there. And then one morning, about 4 a.m., I had another one of those bright ideas, and said, hey, why don't we put this on an e-NABLE hand? And that kind of evolved to using conductive filament to print the fingertips with, and using steel thread to connect those fingertips back to the processor. So that's the idea. I've learned more about how they work. You know, I used to think it was that the human body was grounded, and when you touch or get close to the center, you get a theremin-like effect because you're grounded, but that's not the case. It's really, what it is the circuit sets up an electric field between the antenna and the ground, and then anything that distorts that electric field makes a sound. Does that make sense?
Yeah, kind of.
So what's gonna impact is what?
My brother's. I said a lot of the noises you were making reminded me of my brother's theremin. Right after I got that for him.
Oh yeah, did I make a video of it?
You had a video that you had posted that had you playing with basically a pair of wires, and you were waving your hands near them.
Okay.
And that's
yeah.
very similar to how a theremin acts.
Is that one where I was like peeking out around the? I had myself showing it on the screen. Yeah.
Yeah, you have to move your windows around so that you can have your the equipment you were playing with, and the video window visible all of your.
Yeah, those are fun.
I actually got some conductive ABS. Just arrived a couple days ago, so I might have to get my printer up and running again so that I can start playing around with seeing if I can create feedback from fingers like you were playing with.
Do you have an Arduino?
Not on me, but I can drive to Walmart, I can drive to Radio Shack and pick one up anytime I want to.
Arduino is one way to do it, but really any platform that you might have, if you have a Raspberry Pi or anything
I've got a Raspberry Pi. I think we've got some AT-Tinies sitting in the house here somewhere.
Okay, the Tinies will do it. You know, the Tinies won't run the Arduino library. I tried,
Right.
but they will. The Arduino will. But it's really simple. All you do is you make an RC circuit by putting a resistor between two digital pins. Okay.
Mm-hmm.
The one is a stem pin, and the other is a response pin. And you put the wire on the response pin, the resistor between them. So that forms an RC circuit. And then you drive the stem pin high and wait for the response pin to trigger. There's some hysteresis, so next you drive the stem pin low and wait for the response pin to trigger. And so on you go. So you go with high and low as many times as you want. And whatever total time you come up with as a delay for a given number of cycles is proportional to the capacitance. Does that make sense? Is that clear?
Mostly.
You're just making an RC circuit and you're toggling it.
Right.
That's all. And you measure how long the toggles take.
Oh, that's fun. You're already using. Okay, so context for anyone that's wasn't around or didn't watch last week's call. This is a paper that I read from a guy named Dan Oakes that talks about how he made, for like research purposes, force sensitive skin. And he says to use something called a multivibrator, which is a thing that makes a binary square wave output, basically just going on and off, and the period of that depends on the capacitance around it, which is exactly what you're talking about, Les. So you're using what they term as a multivibrator. So that's awesome then. All you need to do to make that into like great like sensing stuff is put shielding on it so that you cut out the so the paper explains that you get a bunch of noise from like you get proximity essentially. You get proximity sensing.
Yes.
And that's like kind of cool. Honestly, not magnificent because it's going to be inherently super noisy, and you're never gonna get that smooth enough to say hold my hand 2 centimeters from this or like hold a given distance, and you won't really say like grab softly so I don't break this egg. So what they do is they put a conductor in front of the sensor that is just enough to cut out all of that high frequency stuff that conveys that information, I suppose. And then all you get is the pressure sensing aspect of it. So they even list some, well, I mean, they describe how to build exactly what they made, but they even list some flexible conductors that can be used for that shielding layer, which is great.
I don't quite follow how the shielding works. How does that go? I mean, where is it physically located?
I'm hazy on E&M. It goes, so if you look at their, if you scroll down to page, well, there's one on page 3, near the top left. They have a sort of sandwich diagram of everything. So you've got your sensor circuit on the very bottom, then a shield behind it as well. So something conductive behind it, and then you have your little capacitor stack built on top of it, and then you have a shielding layer on top. And what you end up sensing is the deformation of that flexible capacitor between the shielding layer, and everything else gets hidden. Okay, yeah, so that's what I was missing from my explanation. The flexible capacitor is the
what I'm
part.
thinking of doing is totally different from that, but it's very similar in the electronic sense, like you said.
Mm-hmm.
It works on the same principle of a multivibrator. The term multivibrator was used
super
to my
generic.
knowledge.
Yeah, I read the Wikipedia. It changed like many times. For a while, it included flip-flops.
Yeah, and it was referred to. I know it from 555 timer history, and the old 555 timer had names for its circuits that were, shall we say, inappropriate for the workplace today, like a multivibrator when you think about it. So they changed it, and they don't use that term anymore. But you know, that's the history of electronics. But anyway, the capacitive sensor library that you can load into your Arduino chip does work in a similar fashion, same fashion, as you say. But the arrangement I was thinking of using is a little bit different. What you're talking about there is making a little circuit when the circuit is on the finger, and you make a capacitor around the circuit or near the circuit, and you sense the deformation of the capacitor, right?
Mm-hmm.
That's a cool way to make it into a touch sensor, I think. But it's not possible for me to make the circuitry that way. I guess I could with an AT-Tiny, but I don't know. The way I was thinking of doing it was the following, and this may not work, but let's try to imagine it. On the back of the tensioner box, we put an Arduino. It's a miniaturized Arduino from Adafruit. Their Trinket, their Pro Trinket. And the Pro Trinket, you know, they've had the Trinket with the AT-Tiny in it, but now they come out with a Pro Trinket that has the AT-Mega 328 or whatever's in the Uno board. It's like a little Uno board almost. And that means it'll run the capacitive sensor library. What did you say, Trouble?
Yeah.
It's like an Uno, only slightly larger than a USB pen drive or thumb drive.
Yes.
They're itty bitty.
It won't do communications over the USB, but it will program over the USB. And they sell. Go ahead.
You just need a FTDI plug, don't you?
No, for this one you don't. It has the communication chip on it, but it's only for programming.
Okay, that makes sense.
I'm not familiar with the chips myself, but apparently it's cheaper that way. So anyway, that's what I'm using because it has a little backpack, which is, they call it a backpack. It's a daughter card in the old terminology, and it connects the battery, which is the lithium polymer rechargeable battery that I'm buying for this project, and it'll recharge off of the same USB connection. So the recipient, the design concept is the recipient receives a device that they can program, or they can recharge with the USB cable. And so this processor resides behind and its battery reside behind the tensioner box, and then we use metal threads to go out to the fingertips, and the fingertips are conductive. So the electric field actually exists between the fingertips and the ground, which it resides on the back of the hand. So we have the field like this. Okay. Then when you place this near metal objects or in contact with metal objects, it changes a vibrational motor or a speaker, either one, at the choice of the recipient. That was a lot of talking. Did everybody follow?
I was kind of doing a few different things, so I didn't really follow, but maybe this is a question for you, Les. My friend 2Cubed, he asked, why the Pro Trinket rather than the Arduino Pro Mini?
The Pro Mini is what I've always used.
Well, with the Pro Mini, wouldn't I not have to buy an FTDI cable in order to program it?
Yeah, but I mean,
I'm not too familiar with the Pro Mini. And it doesn't come with a backpack. So the battery charging, you'd have to remove the battery connector and plug it into a battery charger. Right? Is that correct?
Oh, that's weird. So, sorry, I'm just reading about the Pro Trinket here. What a weird little device. It has a USB port for programming, but it also can do serial communication through an FTDI cable, which is like $3. So, Kind of a weird design decision, honestly.
FTDI cable is $3. I thought it was 15, but whatever. It's low in cost. Well, the main reason is cost, size, and the simplicity of recharging it using that backpack approach. Those are my 3 reasons. Should I choose your alternative for other reasons?
I think.
So
I
the
think
Pro Mini is
why.
yeah. The Pro Mini is older, but I can't actually tell what's new in the trinket reading their thing. Oh, it has way more memory. Okay. Yeah, fair enough.
It's capable of running well, for me, the reason I chose it was it's capable of running the capacitive sensor library, yet it's only $9.95. So it's pretty low in price. But I guess you could do it either way. Really,
Yeah, okay. Whatever. Not an important enable R&D topic, which one's doing what, but you should look on AliExpress for, I guess, trinket clones if you're used to them, or Pro Mini clones if you don't mind switching, because you can get them for like $1 a piece, and they work just as well.
Can you link that?
Yeah, sure.
That's really low.
AliExpress. Yeah. I mean, you have to wait $30 for the slow boat from China, but
yeah, if you want to buy Chinese knockoffs, that's cool too.
Well, it's open source hardware. It doesn't. I mean, it's not a knockoff. It's an alternative manufacturer.
Yeah.
Yeah. So these ones are $1.60, but really, you just kind of find what looks best on AliExpress.
That's very low in price, extremely.
Anyways, so yeah, I'm not too clear on the difference between trinkets and the other thing, but I have the the Hackberries CAD files open now, so we can go exploring it. It's pretty cool looking. Hang on, let me just share my screen here.
Well, actually, I'm kind of sleepy. I think I'm gonna bail out.
Okay.
Cool. See ya.
Thanks for hanging out as long as you did.
Okay.
Yes. Yeah,
Have I just turned on an echo by sharing my screen?
I think it was me turning my mute off.
Okay. Test.
Oh, that's nice.
No, I'm still.
I'm getting an echo.
Huh.
My own voice too.
I don't hear any echo. Could it be me?
Could be.
Okay,
Lydia, you're the only one that I don't hear echo.
Test. Yeah, I just muted Lydia for my end, and now I don't have an echo.
Sounds okay to me now too.
Okay, cool. So the.
Am I echoing now?
Nope.
Right.
Nope, all good.
I'm going to turn Lydia back on, and I'm going to turn her volume down so that maybe it'll reduce the echo.
Yeah, or she can just mute when she's not talking.
Okay, that'll work.
Cool. So this is the CAD for the exo hand, the area, I guess it's called. Yeah.
Yeah.
So pretty much what you'd expect. There's in this forearm bit we've got a we've got a bunch of electronics hidden back here. I didn't actually go find the servos driving the thing yet. I'm not sure that they're in here, and it's rather unfortunate that it all came out one color, but whatever.
Right.
So this isn't motors. This is like electronics hiding in here. I guess that's a little sled thing to make their electronics pop out easier. I'm not sure. Anyways, if we go back to the main hand, I can hide all of this stuff. They seem to have another circuit board kind of tossed inside of the hand. And then hide the main body. And then they've got some cool stuff going on. So they aren't string driven. That much I've deduced already, but at least this finger is driven by this servo here. It's a servo built into the hand, driving a gear which rotates the finger.
Wow.
And then it looks like there's a, that looks like a servo is actually riding on the thumb as well to get the thumb adduction and abduction. I hate those words. They're so close to the same. So it looks like they have another servo for that. And then, interestingly, their thumb doesn't bend. It just adducts, so it does this motion. And then, if you look at the finger itself, it's kind of curious, because they have... where'd it go? Wait, this one might be different than all the others. Yeah, it is. Oh, so that in and of itself is interesting, that they have a different finger design for the index than the rest of them. Well, if we look at all the other guys here, they have...
Actually, the others. That looks like the other ones are tendon-driven.
They're not. They have this weird thing going on here, where it looks to me, but I'm not really sure, like you push on this point right here. I don't know if you can see my mouse, but the right tip of the highlighted piece, and that bends the distal joint. And I'm not sure how they're doing the proximal joint. And unfortunately, this isn't like rigged up either, so I can't do any fancy stuff with just moving it and see how it reacts. Nothing's like attached. But so this. So that's how. So that pivots there with the main body, and then that looks like the attachment for the proximal piece. It's actually way down here, which is a curious move as well. And then,
Nick, did they imply that they can 3D print these?
Yeah, I was about to ask. Is this printed?
With FDM machines, that looks like it's beyond the capabilities of my Ultimaker 2.
With some pretty smart tolerances, I think you could, and like support material, but it really doesn't look designed for printing.
Right.
Sorry, I got disoriented there. Proximal piece is actually way down as well. Okay, so I'm not. Then, so does they imply that they can 3D print? Yeah, there's an echo back on.
Yeah, let me just, Eric. Are you there?
Oops, you just muted him. Okay.
I did not.
You know, those almost look like metal watch parts. They got to be so
they're teensy and very impressively built. I'm trying to figure out how they... Oops, I've hidden something that I shouldn't have. That's what's going on here. There we go. Okay, now let's hide the fancy finger. And this one has a joint down here and a joint up there that's driven by this thing, which is linked with that. Oh. Is that what they're doing? That'd be a funny little cheat. And not all that useful. So it kind of looks to me like... I'm not entirely sure how this mechanism works, but it looks like they use the gear to bend this finger, and then that does something to also bend this finger. What does it do? Yeah, I'm not sure what the linkage is here to here, but then these three are all definitely linked together so that bending this right one will bend the middle one, which will bend the left one. And it looks like, I think it's like this one bends a little and causes this one to bend a lot, I think. But it might be some sort of load distributing setup like we do with the Whipple trees. I don't really know. But anyways, I'm getting too off into the weeds. The interesting point is that they're not using cables, they're using mechanical linkages for all of this.
Yeah. Is there a second, or where is the second, or I guess third motor? We saw the one that's moving the index finger, and we saw the one that's moving the thumb. Where's the one that controls the other fingers?
I think, I'm not sure. Let me check. But I suspect that they're driven by the same motor as the index, possibly. Or, nope, there's, wait, is that, yeah, there's one hiding back here, which, yeah, hide this guy again. So this motor back here drives this thing here, which appears to, they've got like a big chunk kind of stuck through it right now, but it looks like that drives this here, which then in turn drives the pinky. Okay, yeah, and that totally makes sense. So they're directly driving the pinky and then doing these weird secondary linkages to the other two fingers, so it definitely closes like this. I'm almost certain.
Right. Pinky followed by ring followed by...
Yeah.
At the rear of the wrist there, was that a battery pack that you had looked at before under the gauntlet?
Hang on, let me check what all I still have hidden. I think I have hidden more than I should. There we go. Yeah, there's still one. Oop, my bad.
It's running away, catch it.
I don't even remember how to do this in Inventor. There we go. This is hidden, and I can fix that wherever the visibility thing is. Jeez, there it is. Okay, yeah, I don't know what this floaty bit right here is. Maybe that's their EMG sensor. Kind of looks like one. It's got a little port on it and stuff. Yeah.
Yeah, under the gauntlet itself, there was something in form factor that actually looked like a DSLR camcorder battery. I'm wondering if that's what that was with the two.
Under the forearm itself. Oh, you mean inside of
yeah,
inside of here? That is, I believe there's electronics in there, like the main controller board.
Okay, almost looked like a battery pack from its form factor.
Or it might be a battery pack, actually. Yeah, I think you're right, it is.
Slots that look like batteries would fit in it, kinda.
Yeah, I think that's a battery pack, actually. So then, is there... I don't know where their controller board is. I guess that makes...
That might be the controller board inside the phone.
Yeah, I was about to say, I think that makes this guy in here the controller. Visibility. This thing. Yeah, that looks like an Arduino layout, doesn't it? Yeah, it totally is.
Like some sort of...
Wait, no, it's got a big hole in the middle of it.
Yeah, it's some sort of PC board.
Yeah. Anyways, there's their electronics.
Like
So, all very curious. There's another little piece of electronics hiding in there. And does the wrist rotate? That's an interesting question. It looks like it rotates. Oops. Yeah, no, the wrist rotates. That's an interesting choice.
That's cool.
Don't know how they're driving that.
Is that a push button on the top to index or lock it?
That... Yeah, I have no idea what's going on in the I'm gonna unhide everything real
It
quick.
might be a manually rotated wrist. You push the button,
Yeah,
twist
it's
the wrist.
entirely possible. Oops.
I assume you can lock it in position, but it doesn't look like a driven wrist.
Yeah, I don't see any motors or any gears on the wrist rotation. Just saw the.
Yeah, that's what I was just looking for, and I don't really see any either. Let's go for it. Okay, there we go. That's our wrist mechanism exposed. Oh, wait, does it? I have no idea what it's doing. That thing's super weird looking.
I don't know what that is.
Also, it meshes with this guy here. But
Huh.
Like some kind of transmission or something.
Question. Does it
Yeah?
allow to lock this way?
Oh yeah, maybe that's it.
which way?
It looks like it can ratchet and give several positions of angle.
Yeah, that's
I
what I
bet
was
you're
looking
right.
at too.
It's the Princess Wave.
Yeah, which is a interesting degree of freedom to include. I don't think it'd be that high up on my priorities, but maybe they see some use for it that I don't.
If this is a hand which locks for an adult to be doing trades with, being able to adjust the angle to, you know, lock down to have a tool or something in the hand might make some sense. But I don't know.
Yeah, I guess that's pretty helpful, huh? Yeah, that's very helpful if you're doing like tools. And that's definitely what that is, because you can see that this has like a pretty wide berth that lets you look around with it. So, oh, okay, hang on. Hide those guys. Yep. Okay, so these are definitely push buttons on both sides. You push this one up a bit, and this thing down a bit, and then these stop interlocking, I suppose. Actually, wait, I still don't get what
I think the
what
top
pushing this
button.
one down does.
I think the top button allows for rotation, and bottom button allows
Bottom
for,
button. Yeah, angle.
what do you call that? Yaw. What do you call that in medical
Yeah.
terms?
Adduction and abduction is, I think wrist. No. That's that's right. That's right. And then this is flexion and extension. And God only knows if any of my directions were right on those, but it doesn't really matter.
Yaw versus roll.
Yeah.
That's a pretty intricate mechanism to have worked out. If they've got it working, that's pretty cool.
Yeah, I really don't think it's FDM printed. That looks like object parts is what that looks like.
I can't imagine
like
how much
something
force
that-
back through that it would take to shear those parts, though.
Yeah, object parts are not that tough, so probably not that rugged of a mechanism. But this, yeah, actually looking at it now, this looks exactly like something someone in my lab would design. The people that never use FFM, they just use the inkjet machine, and like people say that 3D printing lets you ignore like complexity and all that, and it's totally true with the inkjets. They come up with the most insanely convoluted stuff, but you know they get away with it because they can make it. Anyways, so yep, that's the exo hand.
I could use some of those internal.
Some of those internal whats?
Oh, I could do some of those internal parts on the SLA and put them to stainless or even to bronze, but
Oh, that's a good point.
short
Although,
of casting them, I can't see how those things would hold up.
yeah, in casting, you just don't get tolerances like at all. What was I going to look at? I was going to look at the article about this to see. Yeah, that all looks like very beefy material. They have carbon fiber texture on the outside of the arm. I don't know if they're actually doing like pre-preg stuff. It's not that hard, or what they're doing.
You'd be
Maybe
surprised
they're-
at the so you can get into castings, especially if you start with like a good part to begin with. You make sure that you punch in the numbers. My software, when you run
Oh,
it,
yeah.
casting it in, it already adjusts for it, and you can really get to
shrinking?
your final form. You usually dust off
Wow.
thousands by machine
Wow.
after, but you don't have to do much.
Wow, that's much better than I thought it was.
It's surprisingly, there's distortion and shrinkage, but less distortion than you'd think, and the shrinkage is pretty predictable based on the alloy. So.
I'm going to stop sharing here if anyone doesn't have more questions about the Exos CAD.
The XE.
XE, is that it?
EXII.
Right, the
XE
EXO is that. Yes, the EXO is that exoskeleton thing. Gotcha.
Yeah.
So, did I miss somebody posting the link to what Nick is showing us?
Nick, that thumb reminds me of something. Did anybody else?
We all got it on Facebook. It's right here. It's in the chat.
Thank you.
Did anybody else see a recent posting about a month ago by a guy in Japan named Hiro? He was new in our community, and he had a single motor actuating hand and some video showing it grabbing things, and it was pretty impressive. And it was very much like our hands with tendons, but instead of strings for tendons, he had like mylar sheet material that had been cut with scissors or something, and had the equivalent of a whipple tree for adaptive gripping. And one of the interesting observations I had was that one of his videos,
or Lydia actually, you're echoing.
Sorry, I forgot my mic.
One of the interesting things was in a video that the thumb was not moving, but he was able to use his other four fingers with an adaptive grip to, do a lot of useful gripping. And so having sort of a passive thumb is possible. And the hands that I've been making, the thumb is not a part of the whipple tree, and it's working out okay most of the time. So just an observation.
I think he joined us at our last hangout 2 weeks ago and chatted.
Okay. Did he show his stuff at all? I'll have to go back and look for that if he did.
He talked about it a lot. He was mentioning that he was doing, that he was wanting more people to interact with him on designing EMG sensor controlled hands. He was talking a lot about, he was using 2 EMG sensors. One to trigger mode.
I think that was someone else. I think he was from India. Yeah.
Oh, okay.
India, okay.
Anyway, I exchanged a couple of text messages with this guy, and he seemed like a good guy to get to know.
Yes. Definitely.
Yeah.
I can't find him in the feed of the community, but oh well. Stationary hands, or stationary thumbs, sorry, are definitely a thing that we do sometimes. At Amory last summer at Rice, we were working with kids that had just one finger on each hand and only the metacarpal bone to match, so they were missing all of this.
Yeah.
And no thumb. And what we ended up giving them, the only thing we ended up putting on them was just a little thing that wrapped around their little palm and put a thumb out in front of them. It didn't move or anything. It was just
right. Just something to oppose the moving finger, right?
Yeah.
I find when I'm wearing a wristwatch, a lot of my gripping is pressing whatever I'm grabbing into the wristwatch. It creates
an opposition. There you go. Yeah.
Something to oppose against. I don't have my watch here, but yeah, I find that when I'm wearing a wristwatch, I use it as a thumb, sort of.
Very interesting.
And my actual thumb, it has motion from side to side, but it's got very little motion up and down. It's mostly a stable platform that I press against.
Okay.
And my thumb
Okay.
is surgically constructed. It's not. When I was born, my thumb on my right hand, I could grab it and tuck it around behind the back of the knuckles to get it out of the way because it just sort of flopped loose. It was
Right.
usually in the way, so I just would tuck it out of the way, and then I'd use, my fingers to grab things. Instead, I still mostly use my fingers to grab things. And
Well, this is an interesting topic to me. I'm going to pursue that some more because it can really simplify the simplest hands that we're making if we can
right.
not include the thumb action as a single actuator, single cable, single motor, or whatever, making the hand work. So that's good to know.
Yeah. For most people, their thumb is their most flexible finger, or their most flexible finger, their most used finger. But for me, it's not. It's there's not a lot of movement with any of the joints. So I type on my phone with my fingers. I don't use my thumb. I can't type with my thumb.
Right.
When I buy a laptop, I usually, when I'm shopping for them, I look for one that has a little eraser knob and keyboard because using my thumb to use the trackpad is useless and difficult and awkward. And whereas the eraser knob in the middle of the keyboard is easy to use, and I don't have to move my fingers away from the keyboard to do it. Moving down to the trackpad is painful on the wrist after a while. And there's a lot of little things like that if you don't have a thumb,
Which finger do you use on the little eraser thing?
Index.
Okay.
And my index is almost, it's not opposable because it doesn't rotate around, but the span on my finger is almost as great as the span on my thumb.
Wow.
The span between and
yeah.
So alternative hand designs.
Sorry for chuckling during that. My friend sent me something really silly, is all.
That's fine.
Yeah. When you have a
we
minute,
were watching your video earlier, so you were the only person visible for a few seconds. Right, I was waving my hands at the camera with everything else in the background. Yeah, if you want to talk, Lydia, go ahead.
Okay. So there was a hand by another organization. I think it's like Ellen4.
You're still muted.
What?
No, she isn't.
Oh, she isn't. I've got to turn down that level. Oops.
Wow.
Sorry. All right.
Hello? Is that any better?
Yeah, that's fine.
Still some feedback, but
yeah, my internet's been really nasty the past few days. I don't know what the problem is. But can you understand me?
Mm-hmm.
Yes.
You're fine.
Okay.
Yeah, it's other people seem to echo for me when you're on. So.
Yep.
Ah, well, that's really weird because it's never happened to me before. Usually it's the other way around. I have speakers, but it never seems to be a problem. Oh, I did change my setup. That's probably what's going on. Anyway, I posted something called the LN4 hand. I guess I should look it up in the e-NABLE group. But it basically, all it does is, it's this. It's more like, it looks a bit like a wrench that can move like this. So it's for people that have like an elbow, a little bit of an elbow, and then nothing here. And
right.
So it basically just, this part moves and this part moves, and it just kind of goes like this. But I think you have to adjust it, so it literally just, it's static, and then it's static, and wherever you put it, it's static. So that's a very simple design for people that don't have a wrist.
Yeah, that's kind of a lead into what I've been working on. Is this a good time to show some of that?
Jump in, yeah.
Yeah, it's
I'm gonna mute you
a
again.
normally closed grip that is held closed by rubber bands, much like the Hosmer hook. You know, a pair of hooks that a rubber band holds together. And the Hosmer hook is actuated by a shoulder harness and a Bowden cable that's like a bicycle handbrake cable. And what happens is when you shrug your shoulders, it pulls a cable that makes the hooks separate against the tension of the rubber band. And it's turned out to be a very difficult thing to do with fingers, to make a normally closed voluntary opening hand. It's just because of the mechanics of it is tough. There's a lot of friction that comes into play when the hand is under tension all the time. Normally, when we pull on our tendons to close the grip, until you hit resistance, there's not much friction on those tendons. But if you've got a normally closed thing, there's a lot of pull on the tendons all the time. And so any movement causes a lot of friction in the tendons themselves. I think that's what's going on. And I have finally successfully found a way to make it work using rubber bands and a block and tackle pulley mechanism, which I'm just about to publish, but it's working pretty well. And you know, you can pick up all kinds of things, you know, hands-free. And I'll show you how it works. This is a part of a system that I've been working on with Jeff Aaronstone. And the idea is to make a set of components that makes an arm prosthesis that's modular. So all the different parts are interchangeable with the different parts that the prosthetist normally uses. So there's a socket, there's a fairing, there's an arm, and then there's a terminal device, which is one of our hands. And the tricky part that I've just worked out is the arm part that has a block and tackle pulley mechanism in it that you'll be able to see better once I get it published. But there's like 4 pulleys in that that I can print. I print the pulleys in 2 parts, so it's printed flat, and they just snap together and make a little pulley. So that works out real well. And it's a little bit tricky in the wiring of it, but it allows me to use rubber bands. And I found some at the dollar store, the Dollar Tree store, a little bag with about 1,000 tiny rubber bands in it for $1 that are used for hair braids or something. And so you can just keep adding rubber bands until you get the tension that's working for you. So I've got about a dozen rubber bands on each side of this to make it have a grip that actually grips something. So the hand is basically the Raptor reloaded hand, but I've repositioned the thumb, if you can see that. So the thumb is more like the opposition position thumb that's on the flexi hand and on some of the other arm hands. And so that's working pretty well with the Whippletree and the adaptive grip. And it just you know, goes together with an adapter that has a screw on it. The screw screws into the standard prosthesis 1/2 inch, 20 threads per inch terminal device in the place of the Hosmer hook. So you can actually take a prosthesis with a Hosmer hook on it, unscrew the Hosmer hook, and screw on a Raptor, modified Raptor hand in its place. and you can pull on it, pull on the cable that opens the Hosmer hook, will close the Raptor fingers, unless you've got one of my normally closed mechanisms, and pulling on the cable opens it, and the rubber bands keep it closed. And so that'll all become clear once I publish it in the next few days. But it's finally working, and I'm all excited about it. And simultaneously, a student in our lab, Elizabeth Jackson, is
Right.
the one who's working on the exoskeleton for an orthotic hand for a child who's had brain surgery, and he's only got half a brain, so one side of his body's got almost paralyzed, and her exoskeleton orthotic is voluntary opening. His normal relaxed position of that affected hand is closed, and so she's devised an exoskeleton with the mechanics worked out with tendons so she can pull the fingers open. And so there's a couple of solutions to that tough nut in the works, and I'll be publishing this in the next few days. I feel like I'm under the gun time-wise. My anniversary for being involved with e-NABLE is coming up in about a couple of weeks. So it's like, oh, my 1 year. What have I got to show for it? Well, I'm almost ready to show an arm.
Got a lot to show for it.
And so there's a lot of new things going on here too. Fingertips, rubber fingertips. You know the latex surgical tubing?
Oh.
I've cut little pieces of that and just stuck them on the end of the fingertips. And for these tiny little child hands, it works fine. And I've got a notion for how to do it for larger fingertips also. So that'll, the pulleys that can be printed and snapped together, the fingertips, the adaptive grip, the normally closed, and the modular system, all of that's finally come together. And I'm really excited about it. So I've been working like day and night trying to get it all done so I can share it. But it uses the Monet or Monetti. It looks like Monetti. He pronounces it Monet socket that Jeff Ernstone developed. You print a cone, and it's not necessarily cone shaped. I'm making them kind of goblet shaped now with attachment features printed on it, and you thermoform it. It's PLA. You thermoform the cone around a plaster cast of the recipient's residual limb, and so it's thermoformed and then carved out with a Dremel tool. And I've got some video of Jeff doing this for our recipient, whose name is Lucy, and so all of that'll be coming together real soon.
Yeah, I can get that on the YouTube channel playlist once you get that up on your YouTube channel.
Great.
If you want to do that, I guess I shouldn't presume that you will actually put that on YouTube, but if you do.
Yeah, yes, it will. It definitely will. It just needs some editing and stuff. And Lucy's very receptive to being a TV star. She doesn't mind at all. And so that's great. And it turns out that thermoforming of a cone around a plaster cast of a residual limb is it's a technique that has to be learned. I've had some other prosthetists have tried it, and some other volunteers have tried it, and it doesn't come out as nice as Jeff's comes out. So it's a skill you have to learn a bit. But all the things that we do are that way. They seem easy once you learn the techniques, like soldering or something else. It's a little bit of a learning curve.
How does how does that compare to using a silicone cast?
If you have a way to scan the residual limb and use a 3D printer to make a replica of the residual limb and can thermoform around that, that's okay. But the normal procedure is to use the silicone casting material on the body part and to take that rubber mold and make a plaster part that's usually stuck on a piece of pipe that's held in a vise while you form around it. And they do that to make their composite prosthetic devices ordinarily. That's the normal way to do it. They formerly did it with fiberglass. They use carbon fiber and all kinds of exotic materials now. But the normal prosthesis that the practitioners are making are formed that way. And what's nifty about what Jeff's just developed that we are playing with is that you can print a standard form, and maybe there's a small library of sizes that you would use, and you can just pull one off the shelf and print them up to have some spares around, and then form them in a very short time to fit the individual recipient or patient. And Jeff's notion is that he can train people to do this in third world countries where, you know, it'll take some training and develop some skills to do it and to get a satisfactory fit. But, you know, it doesn't take a medical degree. And it's a lot easier and faster than the traditional way of making a socket for, you know, a below elbow amputee. And so we're all very excited about all of the aspects of this thing, having a modular system that we can interchange parts with the standard prosthesis. So more to come on that, but this is the first chance I've had to show it. Well, it's actually the second chance. There's a podcast by a member of our hackerspace here, Bill Horst Cotter, known as the Radical Geek, is just published a YouTube of that. I'll have to get that on out to the community to take a look too.
Yeah.
So any questions about what I'm showing here? I'll be happy to try to, you know, explain things more, but it'll be a lot easier once I've got, you know, all the documentation to go with it.
Are you planning on doing some sort of, you talked about getting people out in third world countries being able to do this sort of thing. You're talking about not just putting up videos, but the drawings, but putting out some sort of training videos or some sort of
yes, that's the long-range plan. And it's not just by us engineers, but we've got people like Jeff Ehrenstone and the professional prosthetic practitioner community involved in doing this too. So he's already made a trip to Nepal before the earthquake, actually. So he's got some friends over there, and he's planning to go back. But areas like that are places where he has intention of utilizing some of the things that we're developing at e-NABLE in our community. And so I'm really excited to be a part of his projects. And it all started New Year's at a little workshop that we had at his shop up in Lake Placid. John Schul and Nick Hall and myself hung out with him for a weekend and swapped ideas, and he showed us how he did what he does. And you know, just sharing ideas, this thermoforming of 3D printed parts just evolved out of it. And the whole idea of the modular thing, several of us have been thinking about that for some time, and it's finally kind of coming together.
I like it. Is it going to be something that's going to be probably a different conversation, but is it something that's going to be integrated into the Hand-O-Matic?
Yes, very definitely, eventually. But we've got to go through all the beta testing and stuff like that before it becomes ready for prime time. But that's my intent, to get there. And the first beta tester is the child named Lucy, who received an RIT arm back at the Baltimore thing last September. And, you know, it has served her well. But the normally closed grip is going to let her ride her bicycle without training wheels. Her parents wouldn't let her take the training wheels off her bicycle when she was just putting her little short residual limb on one of the handlebars and only had a good grip on the other handlebar. I'm thinking with this normally closed grip, she would be able to feel safe, you know, with a relaxed grip on the handlebar. And so, you know, it'll allow you to do all kinds of things with the adaptive grip. You know, you can just use it passively without the shoulder harness or whatever to hold your phone, for instance. You know, you can just shove it in with your other hand, and that's really pretty cool. So a normally closed grip is very useful, and the adaptive grip makes it work.
You talked about points of friction. Are there any specific joints or points of friction in the design? That,
yeah, I'm trying to improve on that by making straight paths as straight as possible with no sharp corners for the tendon strings to go around. I'm not sure yet whether the more flexible braided fishing line is better or worse than the monofilament. I've been using monofilament mostly, but bending a pipe is has its own equivalent of friction, you know, and that's going on in these cables and even the small thin fishing lines. So that wires that you're going to flex a lot, of course, they're braided wires instead of the solid wires for that very same reason. And so, yeah.
This is going out on the internet. This is going to be posted for public consumption, correct?
Yes, it is. So we're all totally open source and pleased about that. That's the way to go. We've made the progress that we've made by sharing everything and building on each other's ideas. The evolution of the Whipple tree is a great example of that.
Absolutely. As
that Nick Parker here took John Schull's little sketch and played around with it last summer, and then Steve Wood jumped on that and said that it looks like a Whipple tree and made this little 3 triangle thing, and it evolved into my single triangle thing, and then Jason Bryant in China has, you know, taken it to the final end result and put it on a Raptor. So that's really great.
So Skip, speaking of Jason Bryant, you were talking about the friction in your hand. Jason Bryant has been doing a lot of designs where the fingers actuate farther out before they actuate at the knuckle joint, where he was routing the cables across the front of the knuckle.
Yes, indeed. I'm aware of that, and I've played around with it some, and I haven't really gotten back to it because I don't have any conclusive experiments. But there are a lot of ways to make that happen, and
you know, with that,
Fairbairn Hawthorne's hand does that just by the geometry of it, apparently, and
right.
And the hands that I've been working on, Jason's design worked against me rather than for me for some reason with the geometry that I'm using. But I've redesigned fingers, and I've got some printing now that I haven't tested yet that I'm hoping are going to be even better than what I'm playing with now.
Cool. Yeah, I'd like to see if that helps with the friction, if that helps with the tension, if it makes the fingers easier to straighten or not.
Yeah, and oh, by the way, why this is working with the block and tackle is it gives me a lot of flexibility with the mechanical advantage, and I can trade off force for displacement. like high gear and low gear, and
Okay.
so I don't know how much displacement you get with a typical shoulder harness actuation. I've got some inquiries out to Jeff and Nate Ramsey and some others to get back to me and tell me what I can expect Lucy to be able to do with her shoulder harness. But I'm having to move my Bowden cable about 2 inches to get my fingers to open and against the tension that I've got. But you know, with the 4 pulleys, I've got a whole range of configurations that I can use. And the rubber bands are only having to move like a 1/2 inch.
Can they be cammed like a compound bow? They don't have to be round.
Yes, they definitely could. And so all of those things are open open for development. If you've got some ideas, go for it, you know, and build on what we're doing.
The reason I mentioned to ask if this was open is I can't talk about it in detail without violating some NDA stuff at work. But one of the companies that we work with has supplied us, they make bearings, and they've actually formulated some of their polymer bearing materials into some filament to have us test. They're actually printable bearing surfaces.
That's cool.
I don't have very much of it. We can discuss details some other time. But if you'd like,
yeah, well, we're going to end up walking a lot of tightropes about, you know, not stepping on toes for people's proprietary information. So whenever I'm talking to anybody, I just tell them right up front, you know, don't tell me any of your proprietary stuff because everything I'm doing is open source. And
yeah, well, so for something that's not secret, IGUS sells tribofilament that's supposed to be pretty solid for bearings.
IGUS makes 2 different kinds of filament, and yeah, it's interesting. They're still kind of teething, and it's expensive, but it does work really well if you can get it to print.
If you can get it to print. We're still pretty limited to PLA and ABS in our lab, although...
I think they're working on the formulations. I think that's where they're debugging it. There's somebody else who's going to come out with a tribopolymer that's filament-based that they're researching how to get the filaments to be consistent right now.
Now, what do you mean by tribopolymer?
If you look in the sidebar chat, Tribo is the company, right? Or IGUS.
No, it's...
What is it?
IGUS is the company. Tribo, I usually hear in the phrase triboelectric. It's, I don't believe that's what's being talked about here. It's very wear resistant. It's very abrasion resistant for some reason.
Okay. Yeah, optimal bearing surface is optimized for low friction, high wear resistance.
Yeah, I'm familiar with triboelectric, Nick.
Triboelectric is friction causing electricity, so tribo is just something to do with friction. Okay, gotcha. Speaking of you were talking about like Bowden cable and pulling it 2 inches. Do you know off the top of your head, first of all, how hard the average person can pull those Bowden cables on the shoulder harness?
No, but I'll be finding out real soon. And you know, I've got about 6 pounds of pull on this cable to make this hand open, and it's not a real strong grip, but it'll hold a glass and an apple and things like that.
Because Adam Arabian, when I was talking about shoulder stuff like last December, and I think Ivan was designing something for it as well. Not sure if that ever came to fruition, but anyways, that Adam was saying the problem with shoulder-powered stuff is fatigue. Apparently, people get too tired using them.
Yes. Well, that's the voluntary opening thing. It's passive. You're not doing anything all the time you're gripping. So it's only to change to another grip that you have to do anything.
And that's why most of the shoulder-driven prosthetics I've seen are normally closed.
Right.
Because if you're holding on to something, you don't want to be exerting weight or pressure on your shoulders to do it because of the tiring you out.
Well,
Right.
so have you guys seen the locking mechanisms that we do sometimes? Or well, we almost never do, but I've seen at least a couple of hands with them.
Yeah, I haven't seen that many hands yet. I've got a lot to learn, Nick. So anything you can share with us about that kind of stuff.
Yeah. So they do normally open hands where you pull cables to close, and then the trick is they just put some sort of latch that they can close on those cables.
Yeah.
So it's a second hand kind of thing, but you grab something, flip a latch, and then it stays.
Sure, and that makes a lot of
And
sense. I mean, we could certainly
yeah.
do that. I've played around with some
wonder if there's
concepts, but I don't have anything ready for prime time yet.
Yeah, to parrot the response that always comes up with, go ahead, Trouble.
I was going to say, I wonder if there's a way to, you flex it and it latches, you flex it again and it releases.
Oh, yeah,
so that
yeah.
Yeah, that's doable.
Debbie Ling was talking about doing that with a ballpoint pen clicker. That would that would be pretty cool.
Roller locking mechanism.
Yeah.
Yeah, that would be one way
Yeah.
to do it.
And I was gonna say that puts you at one grip position, but it doesn't have to, does it? You can do something where you close past here and it won't go back until you go back and then start closing again. So,
Yeah, right,
interesting.
right.
Someone ought to figure that out.
Or just some way to, when you start moving it, it will latch until you move it again. You would have to move it past where the grip ends to unlatch it, but just a...
well, you don't want that because then you can't get stuff out of your hand. But there's mechanisms you can make where you move past a certain point, they latch, and to unlatch you need to move back and then forwards again. That's definitely a doable thing. I don't know what they look like off the top of my head, but it's definitely a thing for like ratchety systems for.
Right.
I want to say climbing, but it's not for climbing. I don't know where I've seen them, but I've definitely seen those. They're definitely a thing we can make. I'll read about it.
Yeah.
And you can have a grip that is not as tight as being latched. Like I'm very hopeful about this hand working for Lucy on her bicycle, because I'm thinking it will give her control of her handlebar. But if she falls, it'll just, her own weight will just pull it loose. So you've got control, but it's not locked on the handlebar. And I think there's probably a lot of situations where that's okay.
If there's a little elasticity between the, I don't know, maybe somewhere in the fingers or somewhere, just a little bit of elasticity, you can, once it's gripped, you can probably press against the elasticity. You're not squeezing the hand any farther, you're just pushing it past the actuation point to release the mechanism.
Yeah.
Exactly. Something like a roller locking mechanism would do that. You could keep coming forward until you exceeded a certain pressure on it, in which case it's going to come open.
Right.
That's right, too.
Right.
The certain level of pressure could cause the release.
That would limit your maximum pressure to dirt. Beyond that, the hand would want to open, but you can set a triggering point simply on that, because you are right. The hand isn't going to close anymore, but an elastic mechanism inside is going to shift after the hand can't close anymore. Any further movement on that is going to move your can.
And we really have to pay attention to safety concerns. I just realized playing around with these recent hands and arms that I've been making, our regular Raptor Reloaded fingers have pinch points. You can in the joints, the little stop features that keep your fingers from extending beyond straight, that'll pinch your skin and raise a blister if you fall, with your finger in the wrong place. So there's a lot of things to be concerned about and to keep an eye out for.
So that's kind of a good seg into my main summer project, which is I don't like that our hands don't have flesh. I think it's a pretty integral part of both how we grip a lot of things and, you know, not having pinch points and stuff like that, and being waterproof and all of those things. Because, I mean, to give a fun example, you look at, put my iPhone on a table here, you try and pick this up with one of our hands, and you're just not gonna, because we don't have that kind of sticky, conforming friction material
Right.
that fingertips ought to have. So my grand scheme for this summer is in super short to print a skeleton instead of a hand and then cast the whole thing in silicone.
What about printing it
'Cause
with
in-
Nintaflex or Filaflex?
Um,
What about printing it like Steve Wood does with Filaflex?
So first of all, Filaflex, I mean, if you're sticking with stuff that we can print, you're in a much narrower class of materials than stuff we can mix up and pour into a mold.
True.
Filaflex is nowhere near as flexible as silicone can get.
Right.
I mean, there's, to be a little weird about it, there's a reason we use silicone in sex toys. It's because it's extremely similar to flesh.
Yeah.
And NinjaFlex is just, you know, flexy. It's not compressible is, I think, how I'd characterize my problem with Filaflex. It's that
Right.
It's stretchy.
Okay.
It's not.
Have you?
It's kinda constant volume.
I recently put a latex glove on some of my hands and arms, and boy, that makes it pretty grippy.
Mm-hmm.
You know, without having the fleshy padding, but just the latex surface.
Yeah.
Works pretty good.
So
Also,
Yeah, I
color
haven't
here.
tried that.
you talking about overmolding or co-molding over small skeletal pieces? You're talking about an assembled hand that then is
An assembled hand that is then put in a full hand mold.
okay.
Actually, if my new printer is a Rostock Max, it's rather huge. I can fit like it's 390 millimeters of Z, so
Wow.
that's like to here or so. So I might do an arm.
All right.
Yeah, and yeah, to I guess quickly summarize, because I talked about all of this last R&D Hangout. I'm doing the silicone hand first, and hopefully that'll be cool and, you know, work. And pending that working, I'm also going to try to do fluidic muscles powered by water instead of air, because pneumatics are inherently super inefficient. But fluidic muscles powered off of a compressible sack of water on the back that you can squish with the same shoulder forward motion that you use for the hook prostheses. And hopefully that'll work. And if that works, then the third step is to add little configurable valves, either manual push-button valves or like electronic ones that you can use to change which fluidic muscles you... Okay, so first of all, add multiple fluidic muscles, but second of all, add valves so you can change which ones get pressure. So then, just by changing a few valves, you can change between this and that and whatever other grips you want. And it's all powered by the same body motion.
Cool.
Mm-hmm. So
Good luck.
the reason I went through that summary is because if I do like a silicone arm, it will be a fluid muscle powered arm with silicone around the muscles.
Nice. What do you propose to do to make the mold itself? Rigid mold or like a
Printed mold. I've done silicone poured into prints before, and it comes out just fine.
okay.
It's,
That
works really well actually.
Were you talking
Sounds great.
before about when you are squeezing the fingers that having too much material between the joints was interfering with
Yeah.
the
Well,
squeeze motion?
so that wasn't quite it. I mean, there was a little bit of that going on, but it wasn't the main problem. The main problem was that, so you have these two pieces here, and you have a string running between them. And when you pull that string, it bends, and the string is now running like this. I mean, that's exaggerated, but it pulls out away from the joint. And it pulls out away from the joint, and it also shortens. And the pulling out away from the joint part, that wasn't that hard. Silicone doesn't really mind being pushed around. That's okay. But the problem was that there was silicone everywhere around this string, so it was through. I don't know why I keep turning off my color. I'm not doing that. It's just automatic. But anyways, there's a tube basically that this string runs through, and when you pull that string, it's almost like it's a Bowden cable, and that tube of silicone needs to be shortened the same amount as the string. And
right.
And I guess like compressing silicone significantly in one direction is way, way harder than pushing it slightly to the side, which is stretching. So that was the issue before, but I have a way to fix that. I'm just going to route all of the tendons through balloons, and then maybe probably through balloons that I inflate slightly before the casting, so there's little air pockets at each joint.
Yeah, now if you're using tendons, you got a lot of friction. If you're using rubbery materials, most of them have high coefficients of friction. Okay.
The nylon string we use, for whatever reason, has a very low coefficient of friction against these materials. I cast just like a straight line of nylon through a chunk, and it was almost enough that it would slide down from gravity for like the bottom of for a little puck about this big and like this thick was almost sliding through a piece this bit with
sounds like you need to print some soluble supports or make something inside.
Yeah, so I don't need soluble stuff. If I had soluble stuff, I'd do much crazier things like a circulatory system, but that's not happening. My current plan for oxygen cured silicone to make it self-healing. It'd be fun, but that's silly. My current scheme for making tendons free is those balloon animal balloons. Just make all of my nylon thread, Lydia, not like nylon. Make all of my passages that the tendons go through slightly bigger, and then put strings inside of balloons, inflate the balloons a little bit before casting, and then the air excludes the silicone both from those little passages, and it makes little bubbles out of the joints themselves. I'm pretty confident that'll work. Pretty confident. I mean, I don't see why it wouldn't, unless like my silicone dissolves my balloons, but then I'll just get different balloon material.
Or a light closed cell foam or something like that.
Mm-hmm.
I think we were cutting out either JC or Lydia were trying to talk. Actually, that was quite a while ago. Did either of you need to say anything still?
No, that was a while ago, but when you were talking about the stuff with Jason and the dental bands, we built one of those hands. I actually had one here, so if anyone was interested in how the fingers worked on that with the dental bands and the that like bar he did right under the fingers, we finished it. So I had it, but that was a while ago.
Oh wait, does that hand have locking? Was that where I saw that?
No, it doesn't have locking,
Okay.
but the fingers move with dental bands. They bend differently. They bend more like your fingers do. So the joints they bend in the other order. Sorry?
What was the bar you mentioned?
With the cables run, there's like a little bar right under the fingers, and the cables run over that bar and underneath.
I remember that. Yeah.
Remember that?
Yeah.
Changes the direction of action. finger order of actuation, external moving towards internal, as opposed to ours, which is internal first and then the others close. Yeah, Jason Bryant put a small bar across the front of the lower knuckle that the tendon routes in front of when it goes through this joint, so that these knuckles actuate before these knuckles do.
And
Yeah,
that's been usually happening for me, just without any special effort.
Right.
Yeah, I had something I was thinking about, but I can't remember what it was. Wait, I figured it out. So when you showed your hand holding the cell phone, it reminded me of some pictures that Jason Bryant has of the arm he's been working on. Arm he printed. Is it the same one?
No, but his Whipple tree works the same way. So the adaptive gripping is the key feature, and his was a normally open, voluntary closing hand, I believe. But it still works because of the adaptive grip. And so mine would passively hold a phone. His recipient would be providing an effort to hold on to the phone.
The other phone gripping related detail of Jason Bryant's fingers was that the shape of the fingertip, instead of the rounded ball like a lot of our fingertips have, his had a more angular, which allowed more precision gripping, able to reach down.
More like a real finger, where you have a arc up to a point and then it goes back. There's a discontinuity instead of just rounded tip.
Right.
Yeah.
Yeah, I've been playing around with that too. I like it.
Yeah, it's a pretty cool design change.
So, are we too far away from talking about the passive thumb for me to show off the Ellen Forsythe again?
The what?
Well, I've been looking at that
no.
while we've been chatting. It's an interesting looking hand.
Okay. I can.
Got the finger
share it.
mesh like hands do.
Yeah.
You know, when you 4 and 5 fingers mesh together, or if you've got 3 and 2, the fingers mesh together.
Yeah. Who wants to screen share?
I can probably do that.
Because I found a good picture of the stuff.
At one point, we also talked about a posable, settable thumb, a rigid thumb that was posable and then lockable. Is there any further development on that?
There have been a few designs that do that. I think that one of the variants of, I'm not sure, maybe Raptor Reloaded, maybe Falcon, maybe, I don't remember. I don't remember the name of the hand in question. But one of the hands had where you could move the position of the thumb, and then the actuation would follow a path when you pulled the tendons. But there was a lockable joint that could be unplugged and then re-rotated, and I don't remember who did that hand design.
Yeah, I had a moving thumb, a repositionable thumb that was an adaptation of the regular Raptor back some time ago, and I played around with making a hand that I could use to hold a fork and so forth. And
right.
You know, that's definitely an objective of mine, is to have a repositionable thumb, and it's kind of like next in line to go on these things.
Yeah, it worked with the for some of the the dial indicators and the like. There's those flexible linked shafts you can arrange your dial indicator on and then set the lever and they lock into place. I think we discussed something along those lines.
Yeah, I've seen those.
Yeah, something like that could probably work fairly well. Putting a cable in tension, putting joints in compression where they lock together. They don't move once they're
Yeah, boy, if you'd come up with something that's 3D printable that, would make that work, that would really be cool. So go for it.
So do you want me to show this video on the bottom of the LN4?
Sure.
Is that right? Yeah, ln4.org. So let me go ahead and start it then. Here we are. Oh, actually, hold on. Let me make myself presenter so that. All right.
Man, that looks like it'll work, but I'm looking at the picture of that kid drinking out of the cup, and man, that hand looks like 100-octane nightmare fuel right there.
It's got that salad tong intermesh thing going on. I've got the volume down really low, and I'm having some network bandwidth issues.
Maybe we can watch it on our own. Video in a video generally doesn't work all that well.
Yeah.
So.
But you can see the hand in that. And yeah, drinking with the water. Yeah, I'll stop it here in a second. So you can see the hand.
Mm-hmm.
With the 2 on the inside and 3 on the back side, and they fingers slide between each other. And yeah, I get the idea that that could be kind of spooky for appearances, but I think it's useful though. It looks like it's something that would hold together really, really.
Yeah, it reminds me of Cool Hand Luke's 2 thumbs.
Mm-hmm.
Yes, that was pretty fun.
Yeah, that's what I thought too. Yeah, somebody could design it so that it doesn't look as quote unquote scary. Also,
Yeah.
make it a little bit normal.
And if you've got interchangeable terminal devices, you can pop them on and off for different tasks. If you want to dress up, put on a nice looking hand, and if you want to, do some work, you put on something that functions right for you.
Right.
Oh yeah, but that same functionality, it looks perfectly functional. It just it could probably aesthetically be not quite so intimidating. I could see it being scary to kids. Wouldn't want to give it to a kid and then have the other kids be running away from it.
Unless it's Halloween.
Yeah.
It's in the sidebar. It's that ln-4.org. Both Nick and Lydia posted it. And the video was near the bottom of the page. I'm running out of things to talk about, and I'm starting to get tired. Is there anything else that anybody else wanted to bring up?
Nope.
No, I think it's a good time to break.
Yeah. Yeah, sorry, I was up fairly late last night, so I didn't sleep as well as I should have. So
I did the same thing.
No worries.
Having a day off never results in me being very alert on that day off.
Yeah.
And Lydia, I see your question asking about how is Jason involved in the projects I've been working on, and we just exchange ideas, using the postings and forum and so forth. And I love what he's doing, and building on each other's ideas is great.
Oh yeah, good time to do a commercial for the forums. We still have the R&D forum, and any detailed conversations over text and stuff would be good to have on there. And then
I'm going to utilize that with my ARM publications in the next few days. I'm going to be seeking beta testers, and people like Christian Silva might be willing to try it.
When you start those topics, go ahead and share a link to the topic to the community so that people know that the topic has started and can get involved.
Yes, indeed. Yes,
Yeah.
indeed. That makes sense.
Yeah, it's good to do that. We got to keep posting in there in the Google Plus group that the forum exists, because a lot of people still haven't even checked it out yet.
And we always have new people that don't know that it's there. So having a way
it gets kind of overwhelming too. There's so much to try to keep up with.
Exactly.
Yes.
That's what the forums are for.
Yeah, I need to join into the forums, and if you need any help, Skip, what you're doing is kind of coming at something we've been working on from the other direction. So if you need any help with that, I think that would be great. I've been out of this for, God, I dropped off the map there for 2 or 3 months. One of the other principal of my company died suddenly, and left us in quite a bit. Of the 3 partners that founded the business, one's now had a stroke and one died in the last 4 months. So
oh man!
Wow.
It's taken me a little bit of time to make sure the business didn't shutter and stayed on an even deal. So I'm trying to get back into we're trying to get back into some of the e-NABLE projects. Hopefully you'll be seeing more of us. But if you need any help with some of that stuff, we're still
thank
around.
you. I'll get in touch with you with the text hangout. Maybe that's a good way to get started. Is that good?
Absolutely, absolutely. I just wanted mainly to let people know I'm still around and I can still do some stuff. I just have not, unfortunately, just not had the time to drop in the last couple of months.
Yeah, thanks for that.
No worries.
I'm gonna bail, but on the topic of forums, if anyone feels like reading one R&D thread, you should read the articles that I posted there that I totally legally downloaded from the academic archive and posted on a site where all of you can view them.
Great.
I think I actually am allowed to republish stuff like that as long as it's privately, and Mediafire is private. Our forums are private, so it counts. But yep, go look at that. The third link is the skin that I was talking about, which I'll probably try this summer because it'd be really easy to integrate into a silicone hand and really cool to have. The second one and first one are both to do with understanding how our hands work and how to make them better by understanding how they grip, essentially. I think it's a really great quantitative way to assess what we're doing, basically.
So are you talking about... Are you talking about 3 links that are on the forums? Because you put 1 link to the forums.
3 links that are in that one thread.
Okay.
Yeah, they're numbered 1, 2, and 3.
Yep. Anyways,
So I copied the link to the comments on the event.
And Nick, I'm going to go now, but one of the things, if you've been working with pourable castable silicones, correct?
Yep. Well, affordable. Yeah.
But pourable?
Pourable, yes. They're a little expensive, but it's pourable.
Well, some of the stuff we use for jewelry is vulcanizable. It has to be vulcanized, has to be heated. It used to be you had to have stuff that was heated at like 350 degrees, so you had to have it in some, decent molds, aluminum mold frames or whatever. They do have stuff now that will vulcanize down to 160 or 170 degrees Fahrenheit.
And remind me what vulcanized means.
Coffee, huh?
What's the advantage of it?
You mean well, it's soft. It's like Play-Doh. It's putty. You put it into the molds and put it in. When you heat it up,
it hardens.
The castable stuff tears fairly easily. Flexibility-wise, it doesn't have the tear strength. It just any of the room temperature poured stuff tends not to be anywhere near as durable for our mold. We'll only get 50 or 100 shots out of a mold, whereas we can get 2,000 or 5,000 out of a vulcanized mold. They're just tougher.
Yeah.
A lot.
So, I mean, I'll look at them. Sure. I mean, maybe they're cool. Right. Maybe I want them, but I've been using Dragon Skin silicone from Smooth On. It's has a really high tear elongation at break, and
Okay.
it's really nice skin kind of durometer, and it pours at room temperature, and it's silicone cured, or it's platinum cured, sorry, which means that you can pour more of the same stuff into like a piece you've already got, and it cures as a single solid mass. So I've been thinking it doesn't matter, well, I won't worry too much about the fact that it's kind of easy to cut up, because I can just give them the mold with it and some extra silicone, and when they
Okay.
want to fix it, when they want to fix up like cuts and scrapes, they can just pour some more silicone in the mold, close the complete hand into that silicone, and it'll kind of heal.
Yeah, I'm not familiar with that, so it may work fine for you. I just know when we're making molds in the jewelry industry, we flex them a lot to get the waxes out of them.
Mhm.
And after a couple of hundred iterations, we're already starting to see deterioration on some of the castable acrylic, or some of the castable silicones, whereas we can get thousands and thousands of molds with vulcanized. So
Okay.
now they tend to be a little tougher if you run into that problem. You can also get them in different durometer. So,
Cool.
might not
Yep,
be of
but-
interest to you. Figured I'd let you know. If you need samples, we have some at the shop I can mail you.
Cool. I'm gonna hop off as well now. See everybody.
Great.
All
Thanks.
right. Me
Bye-bye.
too. See you later. Bye, y'all.
I'm in the process of copying sidebar chat into a Google Doc that I can share with the community, and
Great. See you next time.
Okay, bye-bye,
All right.
Skip.
see you soon, Skip. Oh, let me go off air. All right. We are no longer broadcasting.